2 astronauts going as part of Gaganyaan, the first mission?
I can't tell today because it all depends on how confident we become at the end of the decision making process. After all the unmanned missions, like the 3 unmanned missions need to be done, the abort missions need to be done, and everything goes well, and still there are some residual worries, and we will have to take a call, for a launch. At that time, a national committee is there which will take a call. The Gaganyaan program has to continue. That part is clear. So we need a certain number of additional crew members. So that process we have to start. Maybe in another 6 months we should be able to start that process with the Air Force.
The other thing was that Aditya has now reached L1 point and all that. I heard that there could be some alignment issue, and that is
this alignment of payload is one of the tasks that need to be done at onboard. After reaching there only we can do that. All alignments are done in the ground. But when you go there, you will see misalignment. That will be corrected in software. So that process indicated certain numbers which need to be corrected between 2 payloads. That is called the VLCC and the suit. So that will be set in the process of measurement.
Good morning. We have with us Mr. Somanath, Secretary, Department of Space and Chairman ISRO. So thank you so much for making time, sir.
Thank you.
So I thought we'll do a freewheeling kind of a chat on multiple ISRO programs today and tomorrow. And given that you've already spoken about how this year is going to be a year of Gaganyaan, I thought we'll start with the Gaganyaan questions.
Okay.
So first, sir, in terms of, can you give us some specifics about what stage of human rating the LVM-3 or what will become HRLV has reached, and what kind of work might be left before you fully declare it to be human rated?
No, there are different stages of human rating. One is to understand what exactly is a human rating. That took some time in terms of defining the elements of human rating. I think possibly you know that you need to test everything beyond a boundary that you have tested so far. So an extended boundary of testing is needed for every system. Let it be propulsion, let it be structures, let it be control or avionics. Performance indices become wider. So this is the first element of that. So those proven system went through one more level of qualification cycle to ensure that these boundaries are extended. So it started with the solid rockets, liquid engines and cryo stages. And second element is to redefine the design margins for everything. That is, performance margins have to be increased, structural margins has to be increased, and thermal and any indices which makes it as a margin, then that margin has to be increased. So there are some guidelines, thumb rules provided based on other people's experience. So we first started adopting them because we were never having any such things. So this margin improvement was not easily possible. So what we did is we lowered the performance of the motors. The pressure at which it will operate will be lowered so as to gain the additional margin. So the entire solid motor went through a design reiteration, which made the nozzle change. Thermal margin improvement means we need to put higher insulation thicknesses inside and carbon nozzle hardware thicknesses. Then we have to improve potential dangerous zones, harden it more. Wherever there are likelihood of a danger or a leak or a breach possibility, they have to be strengthened. Though they have not crossed the limit till now, but if you in our assessment they need to strengthen. It includes joints, it includes sealing places where additional sealings are included, joint where additional fasteners are added, thickness need to be increased, that is added. So it went through such cycles of reassessment of the design, and all hardwares have been now modified. 100% modification is completed and all of them have gone through requalification. So that is one level of process that we went through. And even the flight hardware for the first of the G1 mission is also realized in that process. But the very important element in the human rating is traceability. Traceability means that when you use anything for Gaganyaan, that should have a 100% traceability from where it started, including materials. There shall be no possibility of a mix-up. When you say certain alloy, aluminum, and this alloy only you used, there is no, once you make it, you cannot assure it is that alloy. From the raw material to this, it has to be controlled, which includes its quality, it includes its non-destructive evaluation or flows inside, strength, that guaranteed strength should be there. So it calls for certain traceability and control of materials, processes, etc., which requires quality people to be always on the site. Then you will also look at dimensions which are potential dangerously that can induce failures, and that dimensions are strictly controlled. Verifications, checks of higher level will happen in the manufacturing. So traceability of the material manufacturing processes go through. It is more stricter in electronics. The parts that goes into it will not be from batches which have a potential problems in. They will all be eliminated. So more qualified, which has more proof of survival are only selected. So design gets then if current ratings are to be are not meeting, then you will have to put a higher current rating devices. So circuits, electronic circuits went through a design cycle to strengthen structural vibration, and all these ways we looked at and look at everywhere where there are potential of danger sitting, strengthen it, harden it. So this process also is completed. So all those hardwares, electronics, packages, systems which requires requalification has gone through the requalification now, and so they are in the flight model realization now, which for the G1. Okay, there is one more point is that finally this rocket is to be certified. The certification requires some committee to look at it, say that everything is as per the Gaganyaan protocol. This process is still not ready, but for that we need to first create a parts tree. That means you consider rocket as a tree. You know, every element is identified. You know the list of whole parts, and every part has a document connected to it, which will go through a verification process, and finally when the full rocket is made, you have the full traceability, everything available in front of you. So this is done by thousands of people. They enter it into a database, on a computer database. Whenever the process is done, checks done, cleared, and this finally it will be seen by a next higher level person, and finally it will come to and launch authorization process. So this is very important certification process. So this is still not fully in the operational level. We are building it, the whole system, the people and the software data. We have fully created the tree, the part list.
So how many parts would?
There will be lakhs of parts, but the lakhs of parts cannot be traced. So what we do is we get an aggregation. So for example, you take an electronics package, it will contain thousands of parts, but then we don't consider all the thousands of parts. We consider the package as one part. So there will be some simplification in that whole process, because the package is fully testable. So you don't have to go into the individual elements. So we look at which requires very go into finer detail, which doesn't have to go. Some of the heritage system may not go to the finer elements of it. So this is one tree and the whole creation. So we will be doing it for the first unmanned mission anyway as a trial basis, but we will have to do it for the final mission. When crew is on board, then it must be complied fully. So this is one level. Any worry, any uncertainty, there will not get clearance, like waivers, deviations. No, they must go through very strict assessment whether this clearance can be given. For example, a thickness change is there. How do you really clear? Dimension change is there. How do you clear? Material property has slightly been lower than the spec. How do you clear? So it will all go through rigorous assessment. So then another important element of human rating is called redundancies building. So the redundancy philosophy has been for PSLV, it is only one system. If it fails, everything fails. When it came to GSLV Mark III, we started introducing dual redundant system. There are some dual redundant in PSLV, but not everywhere. So this is important in all systems, all mission critical systems. We must have enough redundancy. But in Gaganyaan, it is not even redundancy. It is not even TMR, three systems. We need 4 systems. So it's a quadruple system, and all of them are not one fails, other takes over. No, all of them are at the given time working. Okay, so any one failure, the mission continues.
So no time is lost between one taking
Yeah, there is
over
always all the 4 working, and all the 4 is contributing to the mission at a given point in time. There are different philosophies. We discussed redundancy. There is one is working, and if it fails, the second take over. That is called dual redundancy. TMR is 3 are there, and they vote against each other, which is the right, that will function. So when it comes to 4, that principle of voting is not allowed. All 4 work. But when 3 work, there will be a certain amount of deterioration, which is acceptable. When 2 works, it is still acceptable, but then mission cannot proceed. We have to come back and land. We will not proceed, but it is safe enough to come back. So that's why the 4 system. So one failure, the mission goes without any issue, even up to that. And second failure is observed, then we will have to come back. So the 2 systems are there to come back. So this philosophy means every control system, the critical system, mission critical system, all should become quad. This is a major design issue, major design change which we are incorporating. This is required in sensors, like the one which will measure the speed, velocity, acceleration of the vehicle. The computer system, all are becoming quad. The control system which will move the nozzles, etc., will become quadruple. Then all the pyrotechnics, the firing, each firing will have 4 circuits to function. any one firing will be enough to fire it. Like that, but there are systems which cannot be, like engine, there will be only one engine, but the engine is controlled by 4 systems. So like that we have made all the designs. So especially control system, all items are ready, all pyrotechnics all are ready, computers are ready, software for that is ready. So now the simulations are going on. The whole system will go through some very test beds. So those test beds, we have now the number of test cases will increase multifold. So that process is now going on. Testing and validating the software is going on. Now another part of the Gaganyaan human rating is called the intelligence that you need to build in to identify failure. So identification of failure is a very tricky thing. So how do you really say if something fails? So for that we are making another set of computer. This is not the primary computer. This another computer is an observer. It will look at the.
Its job is only to observe.
Only to observe the rocket and measure and look at the measurements in an independent way, not the primary computer. Primary computer also can look at it, but we are, because that can fail. So if that fails, there must be somebody else looking at it to see whether you have failed or not failed. So we put another 4 set of computers. That computer look at the measurements. It collects all the measurements which is there in the vehicle, which is in the primary bus. We call it bus. So the computer network. So from that it picks all the measurements, and it also picks measurements which are separately provided, and take all these measurements into it, and an algorithm works to check whether at different stages of thing it is going in the perfect way. So we have thresholds, bounds. If it is within that, then it's comfortable. If it crosses, then it will look at alternate sensors to check whether the information here is right or wrong. So we have to have a lot of algorithm to see how it identifies a failure. And once a failure is identified, this computer will send a signal to the primary computer on board to start the abort process. So we cannot, ground cannot abort. Ground, there are some limited abort possibilities, but in flight all aborts are done by this another set of computer which is sitting on board. So once the abort is initiated, the crew escape system should take it out and take the crew safe, and further the vehicle will go. So these are the whole system of whole human rating. Okay, so it's a massive improvement. So all of this has been already done. The intelligence building computer called integrated vehicle health management computer is already realized. The whole algorithm for that, doing this process of checking boundary, is now also made. We are undergoing the testing of it. So we will be putting that in the G1 mission itself in a limited way, though it may not be, it will not be used for the whole function, aborting it as much as possible, because we want to see the whole mission. But if it really calls for an abort due to a failure, it will trigger it also. So we will put in a limited manner in this mission. Then after all this over, this human rating, there are other systems which is required for Gaganyaan, like the crew escape system, crew module, service module. They are the essential human space flight elements other than the rocket. What I mentioned is still about the conventional rocket. Yeah.
So sir, when is the G1 mission expected?
Today the rocket, all stages are almost getting ready. The first, the S200 is already prepared. L110 is in completed assembly. Cryo stage is just getting completed. Another 1 month it will be ready. But what is not ready are the human side of it. They are all new items like the crew module. Just the work at VSS is completed. It's moving to, today it is on the road. It is moving to Bangalore to get to come here, and at URS it will come and have that system integrated. The crew escape system hardwares are all ready at different locations. So once the crew module is completed, then we will start the integration. So we looking at the current schedule, it takes about 80-70 days to complete the assembly and then reach launch. So hoping that by June-July time frame we should be able to make the launch.
So G1 will not have ECLS?
It will have ECLS.
It will.
So what we are going to do is we are going to have a version of an ECLS in a simulated volume. The entire volume is not pressurized. The crew module is not a pressurized crew module. Because of that, I am putting another pressurized compartment inside, a tank, and we will conduct entire ECLSS function within that. So the whole of the ECLSS will be available to do the functional activity on a simulated crew volume.
So this was developed indigenously?
Yeah, all done here.
Was it VSSC?
No, it is done across many centers. Many people contribute. LPSC contribute in terms of making valves, regulators. VSSC contribute for making hydraulic systems, pneumatic systems, motors, fans, electrical systems. And Human Spaceflight Center made a lot of other things through industries. SAC prepared sensors, measurements, electronics, etc. for it.
So now coming back to astronauts, the Prime Minister has revealed their names, and can we get a little bit of understanding of what they're doing currently and what will be the next few months like for them?
See, currently they are going through some sort of a training in simulator. That is a primary work, and they are also going through some sort of coursework studies. So that is what is currently going on, and right now they are also being tasked to go to ISS.
Correct.
So some of them will go to America and to train there in International Space Station and take the flight in ISS.
When is that expected? So
that will be by end of this year, 25,
End of this
24.
But eventually there will be one going to ISS.
Two
and
will
there'll
go
be
for
a
training, and remaining two will go for also training in a ground-based training.
Okay.
So all four will have to go. But out of the two, one is called primary and other is backup. So primary will go through all trainings, backup will go through a limited training, and in case primary is incapacitated, backup will go.
So sir, world over that's how it's done. Usually if you want to send an 8-member crew, you pick 16 people.
Yeah.
So going by that, is it safe to assume that we might have 2 astronauts going as part of Gaganyaan, the first mission?
I can't tell today because it all depends on how confident we become at the end of the decision making process. After all the unmanned missions, like the 3 unmanned missions need to be done, the abort missions need to be done, and everything goes well, and still there are some residual worries, and we will have to take a call, for a launch. At that time, a national committee is there which will take a call. We have currently building it for 2 people, not 3 really.
Yeah.
So when you are building it for 2, we can decide to set only 1 or 2.
Correct.
So that decision will not be now. There is no need to take it now.
Correct.
So, but the whole systems are built for
2
people.
But I think because of the ergonomics and all of that, 4 seats have been ordered because you can't keep ordering.
Correct,
it will
correct.
take time.
For the
and all
people,
that,
yeah,
and suits and everything are ordered in 4, but I think all the systems are being built for 2.
Correct.
Sir, and as a larger plan that Gaganyaan is now not just a one mission, it's going to be a sustained human space thing. I've heard that the Devnali facility that's going to come up eventually will also have accommodation for astronaut families, and a plan is afoot for about 25-30 member pool that we're going to create.
No, we have not made any such plan yet, because that is yet to evolve. Currently we are working with only these 4 astronauts and there are some facilities. What we need to do is that Gaganyaan program has to continue. That part is clear. So we need a certain number of additional crew members. So that process we have to start. Maybe in another 6 months we should be able to start that process with the Air Force to identify a new set of crew members. So that may not be in tens, they will be only in few more numbers.
Maybe another 4 or
Another
5
4 maybe at the best. So they will get trained for follow-on missions of Gaganyaan. And the periodicity of Gaganyaan mission will not be very
Quick,
frequent to start with. So because any mission that goes there, that space station also has to be there. So 2028 only we are building the space station. Even then it will not be the human capable. It will take some more time to make it human capable of accessing that point. So we believe it will be a slow progress of induction of people into it. And where the whole facility will be built, their accommodation, etc., are yet to be decided. There we are not. What we are doing there is only related to the ECLS development today. We are only building that facility.
That complex you had inaugurated.
Yeah, that is already happening. Then we will also build the HSFC, the office technical facilities which are required for it, like integration. Today they are borrowing space from URSC. They may also face challenges if you continue there. So that alone is going to be done. But the whole of that, expanding Gaganyaan for the space station and all other activity is yet to be seen. I think we are working on the whole need projection, where it will be physical location, etc. Yet to be decided.
So sir, when it comes to the space station you were talking about, well, a key technology would be the docking technology. So SpaceX, where has the project reached and what might happen?
SpaceX is already almost complete in terms of its hardware. The flight article is undergoing final integration, and we should be able to launch in another 3 months.
Okay. And so far as the test vehicle missions go, last time you had told me that they're not, they can be independent of the G1, G2.
Correct.
So when is the next one likely to happen? Because we've had one, and will there be another pad abort test also?
Yes, the test vehicle is, second vehicle is already ready. It has already come to SHAR. So only thing is that again the crew module side work is, we are working for G1, we are working for test vehicle, we are working for a PAT. So 3 activities are going on. So there is a lot of resource crunch today. So we are trying to see how which can be prioritized. So in my opinion, we wanted to push the G1. So that is what is going on today. Just following that, the TV D2 hardwares will come, and following that PAT will come. And there is one more thing called IADT, the integrated airdrop test. So in fact, 4 assemblies are currently happening at multiple places. So we will see based on the progress of the work, because all of them require parachute, all of them require pyros, avionics, integration, testing.
So will 3 of these 4 can be expected this year, sir?
Yeah, all 4 will happen this year.
But at least 3 we can be
Not
sure.
all 4 will happen, has to happen, otherwise we are not meeting any schedule.
Okay.
In fact, we want to have at least one more D3 flight also this year, A1 flight we call it.
What was
TV,
yeah.
next mission also we will have this
Okay.
year, maybe by the end of this year.
Okay.
That is, vehicle will be ready, but the making the crew module has been initially took some time, but it slowly it will get accelerated.
now
The
that
pace will increase
pace
because
will
people become familiar. So the way work will happen will also improve.
So now getting back to some of the other things, NISAR, you had said the first quarter of this calendar year, but now we are already in March, and I think GSLV is still being built. So when is that expected? So June, July?
See, vehicle GSLV will be built by March, April time, but NISAR is still undergoing testing.
Okay.
It looks like satellite may be delayed. So we are looking at some delay in NISAR.
So maybe the second half after
Second half, because it's not linked to the rocket. Rocket
Correct.
is going to be ready.
rocket will be ready. And so there was another major project with the French, the Trishna.
Yeah.
What is the progress on that?
Trishna was something which was going on for a long time,
Correct.
but we never got approval from government. Now we got approval.
Yeah.
Last Space Commission cleared the Trishna, so the project teams are formed. So they are discussing with the concerned French side. The French side, the approach is that they are building this payload through another agency. So that contract is given. The building is happening now, and the industry, which they have contracted the payload to be done. It's a thermal imager, and our side work is progressing well now. Yeah.
So sir, and NGLV, which is going to be the big ticket rocket for the space station and eventually taking Indians to moon. What is Surya, sir? SOORY, I think.
No, that is only for identification, because NGLV is a new generation launch vehicle.
Correct.
Yeah. So every launch vehicle when it is built is new generation. So that is not a good name. So we must have an identification to start with. For that, for the project to identify it against other rocket work, so we have given some name to it.
Okay.
But then the whole process has been going on for last 1 year. So the committee has completed its design, preliminary design, I must say, across various centers and submitted the report.
I understand that the project team has now been formed.
It's already formed.
It's formed.
The project team is formed. This is basically to start the engineering of it. Right now what he has done is a preliminary design. Now we have to go to every finer nuts and bolts, and that specialists are required. So across all centers we identified a list
Very
of
capable hands of VSSC.
Of course it will be capable hands.
The LVM PD will
all of them will be Mark 3 veterans,
veterans
and PSLV team members,
some
SSLV.
SSLV.
So I have drawn from all of them and then put together.
But the project director will be Mr. Shiv Kumar?
Project director right now is Shiv Kumar, but he doesn't have long innings left. So he will work for the early part of the project. Then after that, next generation will take over. So we have put a continuation plan in the project.
This next generation now brings me to that other question.
Yeah.
The URSC director is due superannuation, HSFC director is due superannuation, and I think
all of us are.
you still have another year at least.
1 year, yes.
But I think also some other critical things in PSLV, especially mid-management. Is that a slightly a crisis kind of a situation, sir? Or
see, always it is there. So when senior leadership leaves, there is always some disturbance, vacuum created. But what we can do with this only to enable the next generation of people to take over. So placing the people at the right location is important. So I am looking at it now. There are a lot of changes in the recent times happened. Project directors have been, new set of project directors have been identified. PSLV got a new project director. GSLV Mark 3 project director is also retiring in another 1 month. So we will place new set of people. GSLV also has same thing. And of course, Shiv Kumar is moving from test vehicle. Test vehicle already had as a new PD. RLV has a new PD. So next generation is slowly taking over. So there is no worry like that.
RLV, when is the next set of tests expected?
Any day now.
Has it reached Chitradurga?
Yes.
Okay.
So we are waiting for it. Most probably it may happen next week.
So what would that entail, sir? This?
See, we did what we did last time was a nominal test. Nominal test means that we go to an altitude of around 4 kilometer, then drop it from there, aligned with the runway. So the whole process of landing is only in one plane.
Correct.
Now suppose it is dropped here, will it come and align?
Okay.
So it has to have other boundaries. So we are shifting the whole dropping point, and see that it takes detour and then come back and land. So these many such things have to be done. We'll have to go on extending, so, and then other conditions have to come, wind, drop conditions, and other failure scenarios. So we'll do sometimes.
Chitradurga has a limitation in the sense that the altitude.
Altitude is limited by the helicopter's capability. Nothing to do with Chitradurga. So that will be able to go.
Okay.
So this time what we are going to do is to do a drop test with a lateral drift.
Okay.
And see whether it manages the mission.
The altitude will be around the same 4 kilometers?
Same altitude, same speed, type of speeds.
So sir, this PSLV, the private one, L&T and HAL, they were also supposed to be ready last time. We thought it would be ahead of schedule. By Feb, they should be able to hand over. Is that
yeah, it is now. It is not. It is going a little slow. So primarily because of the programmatic issues involved. Because any industry want to work, there are many challenges from their side. Their procurements are getting delayed because they are buying for the first five vehicles. So they are not getting materials for 5 vehicles to purchase. So that minimum order quantity issues, and their learning side is also involved even in procurement. So we are helping them in a manner which is slightly not the original plan that they will do everything, but basically they will not be in a position to do, and we will have to help them. So that help is going on, and the vehicle is getting ready. There is no issue. So we have to also tie along with a new satellite called TDS, has to fly on board. So that satellite also linked to this.
But satellite development?
That is also happening. That's an electric propulsion based satellite. So electric propulsion systems are getting ready. There is no issue.
So this will be a full-fledged kind of satellite that
it's a full-fledged satellite
will be tested on.
It's electric propulsion, our own technologies like the TWTs, then some other payloads which will have a very important, which we'll announce a little later.
Okay. A slight hint?
No, it's more for communication, for new generation communication.
So sir, and the other thing was that Aditya has now reached L1 point and all that. I heard that there could be some alignment issue, and that is.
This alignment of payload is one of the tasks that need to be done at onboard. After reaching there only we can do that. All alignments are done in the ground. But when you go there, you will see misalignment. That will be corrected in software.
Okay.
So that process indicated certain numbers which need to be corrected between 2 payloads. That is called the VLCC and the suit. So that will be set in the process of measurement.
Okay. And we'll soon start getting data?
No, we are already getting data.
But those 2 payloads are yet to become operational?
Not in an operation level. That means 24/7 basis it is still not operating.
Okay.
So it has to operate now.
And sir, in terms of remote sensing and communication satellites, there's a lot of big things happening, but like Chandrayaan happened, now we're talking about Gaganyaan and all of that. But these are also some things that ISRO keeps doing continuously. So now, what is the transponder situation, sir? How much?
We're talking about
communication satellites.
Communication satellites, 10 satellites are already with NSIL. We have moved, which are operational satellites, and another 3 more, which are the high throughput satellites, GSAT 19, 29, and one more. Okay, the number I don't remember.
Demand based, that will.
No, those are also, that action is taken to move to NSIL. So it will go the whole process of costing, transfer processes, which took almost 1 year of paperwork. So that will happen to them. So they will have all the 13 satellites in their hand, and they have already launched last year their own satellite GSAT 20, and one more we will be getting launched. GSAT 24 we launched, and now GSAT 20 is getting ready.
That was for Tata Play, and this I think is also a customer driven thing.
Then this for Hughes and others. So this is also getting ready for launch from our Falcon, which will be launched. So, but there are many more communication satellites in the pipeline. There are GSAT 7A, 7R, 7S. These are meant for strategic users, which are currently under different stages of building. We also got an approval for TDS-02, which is going to be a technology satellite in software-defined radio. Fully reconfigurable software-defined satellite, which we already just now got approval from government. And
I
we
think
are
that's
building.
also going to have a lot of strategic use.
It is not strategic, it is a technology demonstration.
But
And once you demonstrate, then it can
Yeah.
use for communication, public use, everywhere it
Everywhere
can
it
be
can be.
used. So because the whole domain of communication is changing. Earlier we used to build communication satellites for 15 years life. But now there is no 15-year life possible for communication satellite because the technology
Technology
changes
is
too
changing so
fast,
rapidly.
and we cannot build a satellite for 3 years. So what you can do is that after 3 years, if the demand profile is changing, then the satellite should be able to reconfigure itself
Okay.
to do a new demand profile of frequency, footprint, the beam, data, etc. So this is the type of demand happening, and everybody is trying to develop, and we are also going to
So
develop.
that is what the software-defined
Software-defined
will
satellite is.
do.
It will be beam forming, the frequencies change over, throughput, feed your data rate totally reconfigurable by commanding.
So what class would these be, sir? In terms of weight, will they be much bigger than
It will be of the typical communication satellites.
As part of the 2047 roadmap, I think the biggest thing would be to eventually send humans on space, and that has a long roadmap, multiple missions, sample return missions. So one, sir, a little bit about where LUPEX is right now, and also about Chandrayaan 4. Chandrayaan 4, has the project team been formed, and who would be heading it?
Chandrayaan 4 is still in the discussion level. It's okay. But we have the internal projects team already formed to do the study.
Okay.
So that is already going on. And the preliminary study and report is already prepared. And what are the missions, approaches that will lead to a sample return has already been studied. But what you are hearing outside is not what is actually inside.
Okay.
So,
So these 2 rockets and all of that?
no, there are many options we studied. Some of the options that you studied are discussed outside, but the final option will differ.
Okay.
Based on detailed understanding. So that is already going on, and we will go through the whole technical side review, the cost side, etc., and then put up the proposal for government for approval. So that process is going to happen. In fact, we have a review. I think it is tomorrow or so that we are reviewing it to give the clearance. Then.
So is this proposal expected to reach the government in the next few months, or?
Yeah, it has to. See, internally there are many steps to be taken.
Correct.
We have to go through technical reviews of different committees. They should say it is okay. Then we have to go through costing review to see the numbers, money that is required, and alternate options, risk mitigation. All this has to be reviewed, and we have to put it in report. After that, we will have to go to Space Commission. After Space Commission, if it requires cabinet approval, that we will have to go. So those steps have to be taken. Then
so at least another 4-5 months we can expect something.
Yeah. Then on LUPEX, you asked about. LUPEX is again a sort of a commitment that we made when Prime Minister of Japan and Prime Minister of India discussed on this topic of engagement. But over many years, nothing was moving because there was no vehicle from their side, Japanese side, to finalize on it. But now it has slowly taken momentum. Our side is to configure the lander. After the Chandrayaan 3, I think the confidence on landers are better.
Correct.
So we have it is a heavier payload, so it is a different lander. So we need a new engine, liquid engine itself to handle it. So that development already started at LPSC.
Okay.
So we have formed it a separate team to develop it parallelly, irrespective of whether it is LUPEX is there or not there. Because we think that we need new engines to go to other planets and land. So that is going on. LUPEX is also configured, the whole concept and engineering of it is already developed, and the teams between Japan and India are all discussing how interface these two. So that's going on.
So sir, in the last many years, ISRO has had several partnerships globally and a lot of bilateral ones, but now seeing the progress that ISRO has made, I've been covering now for 15 years, and I think now, do you think India is confident that you get a table at the big boys club, so to speak, and then also start looking at taking leadership in terms of what kind of policies, because now there is a moon rush, and while there is the moon treaty and also Artemis, which I think India is also now looking to partner with, but is India domestically also, and even otherwise, is India looking at formulating certain guidelines? Because in the US there are some laws passed where if private guys go and they bring back something, they can own it. I think Luxembourg has passed a similar law. UAE is thinking. So now that India is shoulder to shoulder with most of these people, in terms of technology and also in terms of ability to do science. Do you think that role that India would play in these global treaties and guidelines will change, and is there any movement towards that internally?
See, what we have to understand is that globally there are two elements. One is a technological capability. That is one capacity. You talked about Luxembourg. They don't have any technological capability for space. The second side is about policies and statements that you issue outside. Anybody can make a policy and issue that this is our policy. But if they do not have the technological capability, nobody is going to look at you.
The US has both.
See, there are nations with both, because their voices will be heard. Others' voices will be in the sidelines. Okay, they will all be there, the noises will be there, but those who steer this will be the one which have the two types of power. One is technological capability and the muscle power to drive that whole policies. So, as a nation, what we need is first to have the command on the knowledge and skill of this domain. Unless that, you will only be speaking. Of course, you can make an impact in fora like UN, etc., where you talk about various policies and approaches. So, what we thought that in India, what we need to is to expand the scale of the space economy. If we do not do that, there is no point in going further. So, earlier we have been, last 60 years, we have been a national space agency driven by the public funding. And we have been doing certain things for the public good. And technologies were developed with reasonably, with a reasonable amount of Atmanirbharta, as you say, to be done in India, and this capacity has been developed to level. Now what? This is a question we are asking to ourselves. Should we continue like this? At a plateau it has reached and continue? Or you think about an approach to scale up? So, this approach to scale up is very much needed, primarily coming because of the enthusiasm in the private sector today. You look at the private sector, they came forward first to look at how we want to become space-faring people, and government enabled it by opening up the space sector in 2020. So, this means the new age actors who are coming in will have an opportunity to work in space sector. And we also realize that the space economy has to be driven by not government alone, it has to be driven by both private and public. Reason is simple, because there is a business associated with the space. See, this we have not been focusing in the past. All the time we have been doing public funding and developing capability and demonstrating it, not converting it into an operational level. Of course, there are certain operational capability. Communication has become operational, remote sensing certain part has become operational, Navic has become, but driving it through the country to larger reach is not done.
And also looking at outside markets.
Looking at outside market, etc. We are doing launch services as a spare capacity business, not into an operational launch services company we are not made. So, you look at all of this, we see that there is a great potential to do that. So, at least government is looking at possibilities being explored now. So, that is a good thing to happen. So, that means everybody today has an ability, who are wishes to work in space sector are enabled to work irrespective whichever may be the sector. We are also bringing in FDI. That means there shall be no shortage of funds for anybody who wants to do this in India. And the second element is the manufacturing. We have a good manufacturing base today in India, which was not there many years back, because slowly the high-tech manufacturing is happening in India. It is possible for people to come here and build satellites, launch vehicle parts, and use it for global users, which will be maybe cost effective. So, all of this gives an opportunity to expand this. So, once the scale of the activity expands, we will be looked up by others as a prominent space agency. See, even now we are, because the ability in terms of technological capability, but the scale still low compared to many others. If you in terms of monetary investment that we are putting, or the share of our economic activity in space is very, very low.
I think US is some 11 times more than us.
Maybe 7 or 10 or 20 times, we do not know the real numbers. But then the zones where this scale is happening is also different. See, we are mostly into launch vehicles and satellites, but not much into the applications and system building. We are still importing huge amount of this type of things today. Communication equipments, ground equipments, all comes from outside. Now, all of this can be done as part of the space. So, once you start doing it, the entire chain of system will develop around this. So, this is the first thing that we want to do.
Larger ecosystem will be created.
Correct. And once you are doing it, then our voices will be better heard, and we will have a role to play in various fora. For example, looking at moon. Now, we are declared that we are building a space station. That means bring in collaboration. because it is not only we are going to be using it, there will be others using it. Now look at Gaganyaan, the crew module will not be sending Indians alone, it will also be capable of sending others. And we can be used for missions to ISS even. And it can be used for cargoes or transport to other space stations which are getting developed. We are even having discussion with those people who are developing new space stations. So it provides a new opportunity. And we are also telling industries, why not we look at the space station as a potential research space station for economic activity. Going to moon is again a moon driven economy slowly emerging. So we have put it as a plain goal that Indian want to land on the moon. But that is not a small statement, it is a big statement, and it requires huge amount of capability development to happen. So once you realize this capability, everybody will look at you as somebody who should be part of our activity as well.
So you're saying once you land there, we'll talk about resource utilization.
Yeah, this will be in our plan. See, the space resource utilization is not a new agenda. It has been there last 20-25 years. People said we'll go to moon, bring that, we'll go to asteroid, bring all the minerals. Nothing has happened till now. But it doesn't mean that it will not happen tomorrow. So, but we don't want to use that as a simple narrative for doing all of this. We don't want to make high funda words, but look at the brass tacks. The brass tacks is economy, business, out of the space sector. Once you create that, everything will drive on. See, if there is a business opportunity in mining, naturally people with that mind will do it. We don't have to worry about it today. Today, so let us concentrate on technology development and creating an ecosystem for everybody, innovators and startups and companies to come and work. Once that happens, everything will happen. You should not become restrictive. You should not limit people. That's all only thing that we need.
So one last question and we'll wrap this up. For NGLV, when we develop, Sriharikota would require a third launch pad?
Of course it needs.
Because I think 1 and 2, you will need a different kind of configuration for...
Yeah, the vehicle will be much bigger and it will be using methane logs, which is a separate liquid which you have to use.
But so what happened to the semi-cryo, sir?
It's logs methane is semi-cryo.
No, what I meant was, see, from Ukraine, just before the war, I think that we got one engine.
That is the LVM3 version. That is semi-cryo SC-120 is being developed with that engine. So that will operate Mark III in the coming days. See, the NGLV will not be completed in 2 years. It will take 6-7 years. So we have another 10 years to go for LVM3. And we need payload capacity from 5 ton to 6 ton to increase to meet our internal demand. So semi-cryo induction is an essential element of it. But these 2 rockets will ultimately be there.
Okay.
And we will decide whether to retire one or not then, because economics of launches will decide which one is going to survive. Yes. So while we make LVM3, PSL is still flying.
Correct. So
we'll have to see like that. We'll not be making only one rocket.
Thank you so much for the time, sir. Pleasure as always.
Thank you.
From breaking news, detailed analysis, in-depth interviews and explainers, follow the Times of India. Subscribe to our YouTube channel. Don't forget to like our videos and hit the bell icon to stay updated with the latest.